structures can stand for longer than that, in Florida, they are exposed to harsh marine environment that can instead decrease that time. Structures like bridges are made of reinforced concrete that has embedded steel. Concrete has an alkaline nature that promotes a healthy environment for the embedded steel. However, concrete is also a porous medium. This, when exposed to marine environment, means that the particles present in the air will deposit in these pores. Reinforced concrete structures in Florida will face a common challenge: corrosion. Corrosion is an electrochemical process that affects the steel. The result of that is called rust. Now, technically, corrosion is not really in the air. Marine aerosols that contain chlorides are in the air. They generate in the ocean through different mechanisms, such as wave crashing. They travel with the wind and they deposit in the surface of concrete structures. Then they penetrate through the concrete pores until they reach the steel, and that is how corrosion is initiated. Structures are exposed to 5 different corrosion zones, with the splash zone being the one that has the highest corrosion rates. However, in Florida, it has been observed in bridges that are facing the ocean that corrosion has been in the atmospheric zone, the one above the splash zone. Therefore, the main objective of my research is to investigate the causes of corrosion at the atmospheric zone in bridges exposed to the ocean. Samples were taken from 3 different Florida bridges. Concrete cores were extracted from the columns in the bridge, and then they were analyzed to measure the amount of chlorides that have penetrated through the years. Another goal of this research is also to measure the environmental data through a test called the wet candle test. This test allows to measure the salinity in the air by measuring the amount of chlorides present in the environment. Samples were taken monthly through over a year. Now we have 2 sets of experimental data, samples from the bridge and samples from the wet candle. While correlating these results, we are able to observe the trends of how the chlorides penetrate in concrete bridges around Florida. Understanding the corrosion in different areas in Florida on these bridges will allow us to impact the design and also the service life of the structures around Florida by promoting cost-effective, also safer, and overall better designed bridges. So the next time you are planning to go to the bridge, you will cross the intercoastal bridges, have in your mind that corrosion is in the air. Thank you.